No i teraz opowiem wam coś na temat CDS.
Okay.
Zapraszam.
So, hello, good afternoon. First, thank you for coming for my presentation and thank you for letting me be here. My name is Szymon, as was mentioned, and today I would like to introduce you a new tool for continuous integration, continuous delivery that was developed at my company, which is OVH. And I will show the basics, the concepts, and where to look for more. So, during the presentation, I would like to start with sort of motivation. What is CI/CD, so-called? Then I will tell you about few features of CDS. I will give you an overview over the solution from admin points of view. Then I will tell you how it looks, how the architecture looks from the user's point of view. I will tell you how to set up your own instance for testing. And at the end, I will perform some quasi-demonstration how it looks for people that don't want to deploy it now. And I will finish with some roadmap about incoming features. Okay, so first, what is continuous integration? What is continuous delivery? Who is developer here? Okay, so some people. When we are programming something, except of writing code itself, of course, we've got three major stages what happens with our code. First is building. It might be compilation of source code, example in C, or building the package for some distro. Then we have testing, which is running some functional tests or more advanced integration tests on some architecture. And deployment, for example, install our package, build it in first stage here on some remote region. And you might think, okay, so teach me how to do it. What commands should I type to build the package, to send it somewhere? And I will be doing it whenever I need, right? And of course, you can do that. But you know this guy here on the right. Good, good. Let the laziness flow through you. This might work good for you, but there might be one day when you will be thinking what you should dress for a party, or recently there was a long weekend in Poland, right? So you will be thinking, oh, I'm finally going for vacation. Let's skip the tests. You know what happens then. It's 3 o'clock. It's always 3 o'clock. It can't be during the day. It must be during the night when you are sleeping. And something starts to burn. Or it's even worse when you are like this guy here mentioning, you've got only testing environments also in production. This leads to frustration, but it doesn't have to be like this. We've got alternative, and it's called in many variants. It's continuous integration, continuous delivery, continuous deployment. It's mostly about the same. It's just about the details. Here, the most important part is it should be continuous, which means as often as you can. Now you can ask, how often is often? Well, often means whenever there is a need. When you did a change, test it. When you build a package, test it, etc., etc. So if you are smart, you might think, maybe all these steps we have in our dev lifecycle, maybe we can automate it. And CDS is a tool that helps you perform this automatization. Or going to the details, the continuous integration, continuous delivery, etc. itself is very, very deep topic. We would need more than this conference take to discuss about all these things, but we can distinguish some basic principles. First would be that your deployment process should be repeatable. It means when you've got 2 installations, 2 regions, or however you name it, if some things work in region A, some things don't work on region B, we've got a problem. The problem is when in the region A it works, but it shouldn't. Automate everything you can. Of course, this is the thing I mentioned. You can launch tests manually, but eventually you are going to skip it. Because as a people, as a human beings, we tend to be lazy. Just because. If tool will do that for you, it's just good for you. Keep everything in source control. It's not only because you want to track who did some change that has broken your system, but in general, when you will have versioning, you will be able to easily track changes and, in worst case, revert back to the previous working code. Of course, improve continuously whenever there is a chance to improve something, to automate new thing, you should just do it. Build binaries only once. It doesn't mean that I wrote the code, I compiled my program, now I need to start writing new program to do something else. It means that when you've got few installations in, let's say, 5 different regions, you should ensure that you will build the same binary only once, and the same binary will be delivered to all these installations. I mean, there should be no case that you will build something, install it on one region, then rebuild and install in different region. Because in the meantime, many bad things can happen, and we want to avoid that. Of course, test your application and deployment. So not only application, if it works, if it behaves like it should, but also when you are preparing the whole infrastructures, you should also test that it works there. And one of the most important rule that it's not always being followed is if anything's fail, you should stop the line and solve the problem that occurred. For reference and more details about that, I would like to welcome you to visit the following website, where all these points and few more are detailedly described. And as I mentioned, the CDS as the tool helps you to solve most of these principles. Okay, so we know why, and let's see what is CDS. First thing here, my friend told me that I should mention that CDS is written in Go. I'm not sure why, it's some trend. Now everything what is written in Go is super famous. So it's written in Go language, and CDS stands as an acronym for Continuous Delivery Service. No magic here. And what is important here is that CDS is microservice-based solution. It was designed that way to be highly scalable. And second most important thing is that it utilizes the pipeline mechanism. All these pipelines, it's not exactly this as here on the image. I will describe it on the next few slides. Oh, and one last thing, it's released under 3-clause BSD license, so it means that you are free to use it, free to customize it, and adapt to your needs, if there are any special needs for you. And please take a note that the project is still under active development. However, it is already usable, and you can pretty much rely on it. Of course, as any CI/CD solution, it has some basic features that you define jobs, they are executed. Some more important features specific to CDS is built-in job scheduler. So you can define at what time when your jobs are executed. The design of CDS is focused on isolation between jobs. So if you are doing some not necessarily secure things inside your jobs, like injecting passwords in bad way, the CDS ensures that no one from different job will be able to see your password on process list or something. It works on many platforms, basically everywhere where you can build Go binary. So there are classical x86 platforms, but also you can run it on Raspberry if you want, and more and more and more. About operation systems, of course, it runs on Linux. It works on Windows as well. I don't know if I should say that on this conference, but of course, BSD systems, Macs are also supported. For the jobs launching, there are three major backends supported. One is launching your jobs directly natively on the remote host. You just install a service that runs jobs, and whenever there is job, it will execute it. But it's not super good solution. The two last here mentioned are more interesting for us. One is launching your jobs inside a Docker container, and the second is inside a virtual machine spawned on Openstack cluster. I will tell more about that in the next slides. And one thing, currently it offers integration with GitHub and GitLab, and GitHub and on Bitbucket in this public Bitbucket installation, and with this Bitbucket installation you can install on your own infras. The integration is mostly about fetching the projects you've got defined, the branches there, and sending or setting the jobs result to the specific commits and branches. And of course, CDS is extendable by plugin mechanism and add-ons. Okay, so let's see how CDS looks for the system administrator. And for the system administrator, there are 5 binaries, 5 services that CDS utilizes. It's API, CLI, WebUI, Workend, and Hatchery. And for all of these services, there is software development kit available. If you are a power user, you need something very, very specific that is not there yet. You can do it quickly. Okay, let's go through all these services. So first, API. API is the core component of CDS. Actually, it provides not only the application programming interface, but it utilizes basically all the features related to abstraction layer and management of your jobs. It's configured by one single 2ML file. 2ML file is some recent file format. It's very, very similar to INI files, but someone called it 2ML, so let's have it like this. And for API service, there is only one mandatory requirement. It's PostgreSQL database. As the name suggests, it's just to keep the data there. And for very basic installation with one service, this database is all you need to launch the CDS. However, for scalability, there are other dependencies you might need or you might want to consider at least. Of course, there is SMTP server. It's useful for sending emails. you can turn on that the notifications, and you will receive an email whenever your job will finish and what is the status. And some basic, more basic things like when new user registers, he will receive an email how to activate his account, right? There is integration with LDAP. So when you've got installation, you can have users already integrated with your CDS. As CDS is scalable, you can run more than one API service at once, and to exchange data between API services, the Redis is used. Also, it's possible to integrate CDS with Kafka. For now, it's only to manage CDS events, which means it might be useful for your team leaders or someone, because for now all CDS events pushed to Kafka are things like job started at time this, job finished at this time, and you might use it to generate so-called key performance indicators, these business things, right? For having distributed storage for artifacts and other job results, you can use OpenStack Swift. And one last thing, there is service called Vault. You heard about that, maybe? Anyone? Okay, one guy or two. Good, so do notes and write the name. Vault is very cool service that allows you to store keys, passwords in a secure way and integrate it with your applications. CDS utilizes it. Okay, CLI and WebUI. There is no black magic here. For now, the CLI, command line interface, offers the most complete management tool. The CLI is most complete management tool for CDS. And it allows not only to define the jobs, but also to monitor the CDS status. And it's quite dedicated for advanced user. That means there are features in CLI you cannot perform yet from the web UI. Web UI is, of course, user interface available through web browser, deployed with Angular. It was chosen because of speed and performance, as I heard. And of course, it's scalable as the rest of components, which is not very obvious for all web UI services I've seen in the internet. You can spawn many web UIs and with load balancer switch users to have scalability. Okay. A worker. A worker service is a service, an application, an agent that executes the jobs that CDS API tells the worker to do. It connects to API via dedicated server, via dedicated key, and it works that way. You've got your host or something, container, virtual machine, you install their worker service, you get the key from API, you configure your worker to connect to the API with this key, and for worker, you also define so-called capabilities. Capabilities are like a list of things that the worker can do. Most commonly, it's just a list of binaries that on this worker are installed. So, for example, when you've got a job, when you want to clone some Git repository, from these three workers, one of these two will be chosen. When you will be building a Docker container and pushing it to some registry, this one will be chosen. Okay? And of course, user can very easily spawn his own worker. I mean, user don't have to rely on CDS administrators, if he has some very, very tough jobs, like compiling some very big projects, he can just define in CDS his workflow and create his own worker that will have a lot of cores or something. Okay, and last service is so-called hatchery. And this is very cool service because it scales your workers automatically. And which means that it spawns and kills workers just. Now, it spawns workers depending on the current build queue. It means when you are building one job every hour and you will have just one worker, it will be sufficient, so it won't spawn any other worker. However, when there will be need and you will need to launch 10 jobs at once, the hatchery service will catch that there are not sufficient number of workers running, and it will spawn new workers for you automatically. And it supports for now actually the last 4 services. I mean, the first one is not very interesting, but I'm mentioning it to be formal here. Hatchery service can deploy new Docker containers on demand on local machine and can do that on Marathon platform, which is part of, not part, it uses Mesos cluster or Docker Swarm service for you. And the last option is Openstack installation here. When you've got Openstack cluster, you can configure hatchery to spawn virtual machines on your Openstack cluster. Okay, this is how it looks for system administrator. Now, from user points of view, there are several components of CDS. Most of them are just an abstraction layer. We've got their projects, applications, pipelines, stages, jobs, steps, environments, and variables. So let me define what is what. A project is the biggest abstraction. It's on the top of everything. It contains everything else that was on the previous slide. So basically applications, pipelines, and environments. And you can use projects just to manage your workspace. I mean, when you've got company, in company you've got 5 teams, you can create just project for each team to separate their work to make it easier to read. And project can be linked with Git repository manager, the previously mentioned GitHub or Bitbucket installation. Okay, now let's go to this about this yellow part. Application. Application is an entity inside which contains references to pipelines, and the keyword here, references, is important. I will tell you on next slide what it means. Within application, you define the relations and triggers between the pipelines. And one important feature here is you can create application from so-called template. There are a few defined templates in CDS currently. For example, as I remember now, is build Go package. It automatically creates for you the pipelines, like build the package, deploy the package somewhere, and test it functionally. Yeah, and application can contain application-specific variables. I will tell you about it on next slides. And when project is linked with repository manager, the application can be linked with specific repository from that repo manager. Means here that when you've got a project in GitHub and you link your project with GitHub, here you can easily link your application with this project on GitHub. And whenever new commit will be pushed to your project on GitHub, building pipeline might be triggered. Simple as it. Okay, the pipeline. The pipeline is a key element of CDS. It consists of so-called stages, and we have 3 types of pipelines. One is called build type pipeline. The second 2 are deployment and testing. The difference between them is that for deployment pipeline and for testing pipeline, you have to specify an environment when you want to use it. That's all. And what is special about pipeline? Why I told on the previous slide that you are putting actually our references is that single pipeline, let's forget about what's inside. Single pipeline has some definitions of jobs inside. Now, this single pipeline can be used in many different applications. Why is that useful? For example, imagine you will create a pipeline, deploy my package on some package repository, right? And now we are building 10 packages. In classical approach, you will have to define the same steps for each this project you have. And then imagine your repository address will change. So you'll have to adjust this repository address in 10 projects, right? Here with the pipelines concept, you have one job definition based on variables, etc. And you can attach it to 10 projects. Now, when our repository address will change, we will just adjust the single pipeline, and all the applications where we have reference to this pipeline will work with the new repo address, right? Okay, and what about that things inside? One is called stages. The stages are just another layer of abstraction. Stages are containing jobs, and stages contain prerequisites, so-called. It means that you can define conditions within a pipeline that this stage should run only for example, for branch on GitHub that is called prod, master, or something. And one thing important here is that stages are executed sequentially, means one after another, only if the previous one have succeeded. Within job stages, we have jobs, and jobs are actual things that are executed on workers. Each job consists of steps. It's on the next slide. And for job, as it's launched on the worker, you can define also the requirements I mentioned before. So for example, I need that binary on my worker, or I need such amount of random access memory available there. Or you can just specify the specific worker model, what is worker model I will tell you on the next slides. Okay, and within job, the step is a single task to perform. So the simplest step you can imagine is just some shell script execution, right? But we've got also some more advanced actions defined. One can be git source code checkout. One is parse my JUnit report and generate nice dashboard with summary, etc., etc. You can extend that list, of course, with plugin mechanisms. One important thing here is that we can distinguish two kinds of steps, regular steps and final steps. The difference is that at first they are, of course, regular steps executed in order of definition, so also sequentially one after another. And the final steps are executed always after the regular steps, and they're executed always, I mean, when one step here, one action will fail. For example, we will try to clone some non-existing Git repository, or just our script will return non-zero status. The step will fail, it will fail the job, and it will mail the stage and the pipeline as failed. Final steps are executed anyway, and it's useful, for example, when you've got as action, for example, compile my binary or launch unit tests. Of course, when some test will fail, you want to mark the whole build as failed, right? But you still might want to extract some artifacts or generate JUnit summary. This is what the final steps are for. Okay, I mentioned environments. Environments is another sort of abstraction. Basically, environment is a special set of variables. You can define few environments. Within each environment, you have to define exactly the same variables. I mean, the name must be the same, the type must be the same, the value can differ. It's useful when you've got few installations of your big product in different parts of the world. And to deploy something on this infrastructure, you use the same mechanism, however, with different username, with different password, etc. That's what the environments are for. And a variable, the simple thing, it's just some named parameter and value. You can use it within your stages, jobs, and steps. Like, you know, I mentioned prerequisites for stages, so you can define if my application is called that way, execute this stage, right? Or the environment variables, you can just put inside your job definitions the value from that variables. Okay. So we've got environmental variables, project-specific and application-specific variables. I will show you where to define it. And there are also some special variables. The difference is that the first two here are defined by user. The last group is defined by CDS whenever it's possible. For example, the build number is always there. It's always unique. But Git branch name you will have only when your application and project is linked with some Git repository. Okay. And last thing here, not necessarily connected with the things mentioned before, is this so-called worker model. And worker model is a definition of worker for the hatchery service. In the simple words, within worker model, you define, I want a worker that will be using the following Docker image. Or I want the worker spawned to be a virtual machine on OpenStack using this flavor, this image, and run inside on the initialization the following user script. Okay. Now, how to set up CDS for testing on your own? We will perform here a very easy way setup, which means that you will only need to have a Docker service. It's good for testing and playing with CDS. Of course, it's not recommended way of setting it for production. For production, please go to the following web page. There you can find more detailed instruction how to set up everything. And as I mentioned, for minimal setup, we would need one database, one PostgreSQL database, one CDS API service, and one worker to launch the jobs. We will also install Web UI to manage everything. So, first step here, prepare your environment. As I said, install Git, install Docker, add your user to Docker group, so you'll be able to actually play with Docker. And within existing session, add newly added group to the session, so you'll be able to use it without reloading your shell. Then clone the CDS repository from GitHub and go inside the downloaded CDS repository. Step 2, prepare the database. So we've got there the Docker compose YAML file with all necessary definitions. What we need to do is just execute the command docker compose app for CDSDB entry. Wait a while. With Docker compose logs, we can check when there will be notation that the database is ready for accepting connections. We can proceed with creation of actual database with the last command here, docker compose app, CDS migrate, and if everything will go correctly, you will see that about 15 migrations were done, exit status is 0. Then we just deploy an API service and UI service. After typing that command in your shell, you will have web interface available on the following address. Then, as I mentioned, until step 3, after step 3 you can play with CDS, define jobs, take a look how it behaves. But no job will be able to execute. For executing jobs, you need to deploy a worker, and here, actually, not a worker, but hatchery. With the first command, you can deploy local hatchery service that will be using the local Docker to spawn containers. If you've got Docker and Swarm installed, you can use the latter command and see how scalable it is, how many jobs it can spawn for you. Worker service, I mean, sorry. Okay, good. So now let's go to the quasi demonstration I mentioned. There will be just screenshots because I wasn't aware of the internet connection here. So this is first thing you will see on the CDS. It's login screen, of course. And after performing this setup I presented you, first thing you have to do is click here, create an account, create your account, you put your username, put your password, create, and then you can log in here on the main page. This is how currently looks the main page of CDS. Pretty empty for now, but in the future there will be the timeline. You will see your recent jobs and their statuses. Now it's deployed, it's a clean deploy of CDS. So let's create a new project by clicking here in the create a new project on the top. We have to specify name of the project. We have to specify unique key. The key is a reference you use to this project in command line interface when you are using it. And of course you will find it in the URL in your web browser later. We can generate here dedicated SSH key for deployments and stuff. And one thing here, you have to create also a group which will be able to access this project. A group is just a, how to call it? Within groups, you are putting your CDS users, okay? And then create, and we've got our projects, Linuxowa here. Okay, we see it's empty. The black dot here is just some artifact from the projector, so it's not part of UI, if any doubts. At first, let's go to the pipelines page, and let's click there, create a pipeline. For pipeline, for our first pipeline, let's define it with some name, and let's create a pipeline of type build. Now create, with this button here, we can create 2 stages, and within first stage, we can add job, some simple job like this, job started, sleep time for 10 seconds, and the job finished, echo. And the type of job is script, right? Okay, and in the second stage, let's define, we've got job that should fail, so we've got as last action the false comment. It will return 1 status. And let's define final step to see that it works as I told you. Okay. Then let's create another pipeline, the same way I mentioned before, with different name, my pipeline 2. This time it will be type deploy. By clicking on create, we are adding stage, we are adding 1 job, and the job will use a variable as I told. This is, in this example, this is environmental variable. You can distinguish by these 3 letters E and V, right? And from this environment that will be attached to this pipeline, we want a variable called host added there. Right, so let's save our job. This is our pipeline view now. We've got 2 pipelines defined. So we created a pipeline of type deployment, so we need an environment. Let's go to the third tab here. And here on this environment tab, we define our environment called mynv1. And within this environment, we define 2 variables. One is called host added there of type string with some value example.com. Please remember that value for now. And we are defining the second variable called user type string with some value. By clicking the save, it will appear here as added to the environment. Now, when we will create another environment, we will already see these variables here, the same list, but the values will be empty. We will have to initialize it. Okay. That's almost everything we need. Now let's go back to the first tab and click on create application. For application, we are specifying at least the name. We can also use some template, but for now, for this demonstration, I won't use it. By clicking create, of course, we created our application, and this is how the application looks. It's empty, right? Another no black magic here. So we are clicking on attach pipeline, and we are specifying 2 pipelines we defined to add it to this application. Now we click on save, and you will the contrast on this projector is not so good, but we have here 2 pipelines. And now we can run them, of course, by clicking on this triangle on the left in the circle. But first we want to create the trigger, I told you. So we are clicking on the triangle here. This is this triangle with options to the first pipeline reference here. And the last position is create trigger. We click on this create trigger. And we define from this pipeline 1 in my application, we want to trigger the project Linuxowa my application pipeline do 2 and execute that pipeline 2 with environment previously created my env1. Of course, we can also define here some conditions. The same conditions you can define for stage. For example, trigger the second pipeline only if current Git branch is something. Or you can extract some variable within this previous pipeline. You can export it, and you can access it here on the condition screen. Okay, so we defined, let's click create. And after clicking create, we can see here this line. It connects the two pipelines. I don't know if it's just the... Okay, it's just the contrast of screen. All these pipelines are in boxes, so it's more clear when you look it on your computer than on this presentation. Okay, and now let's click on this first pipeline on this button to launch it. By clicking on this button, we told CDS to execute that pipeline. This pipeline consists of two stages. Within both stages, we've got one job here, one job here. And of course, as I told, the stages are executed sequentially, so the first stage is to being executed. For now, it's in queued status. It's waiting for a worker service. And yeah, and after a few seconds, the archery service has spawned worker with very nice name. That's I haven't chosen this name. This is just, you know, accident, but it fits into sesja Linuxowa topic, right? And here we have logs from this job. We see that first job has succeeded, the second job has failed. When we will scroll down, we will see the output from the first job, right? It's that it's from the job 2. From the failing job, we see the logs from the two steps we defined. One step was this job should fail, and we see exit status 1. That's why this script was marked as fail. However, we had also this final step. This final step was executed, as I told you. Okay, now let's go to the second pipeline there. Come on. So by clicking on this, we'll launch the second pipeline in remote environment. Not this one, sorry. So also we have to wait a while for deploying the container. This time you can notice it's much faster. There was about 20 seconds. Here is 5 seconds and the job is done already, because the deployed container has not been killed yet by hatchery service, because I launched the both pipelines within 10 minutes. So okay, and by scrolling down, we see the output from the job defined there. We see job executed on example.com. There was the variable, right? So the variable from the environment I defined was used. Okay. And this is how it will work. It will look after the execution of these two pipelines. The first is marked as failed. The second is marked as succeeded. You might wonder here why, if this failed, this I was able to launch. Is because I haven't put there a constraint to ensure that this pipeline executed with success status before running this, but you can do it with 2 clicks. If this first job would succeed, the second one, after define this trigger as we did, the second pipeline would be triggered and launched automatically. Okay, and that's all for the demonstration. Now 2 words about the incoming features. So as you might catch during my speech, I told that the CLI is so far the most complete management tool. And this is why we need some further improvements in Web UI. It's mostly because that the CDS developers team is contains mostly the backends developer. We are looking for some web designer to make this interface better. Also, there are things that you can do only from CLI. For example, you can export your CDS configuration, the pipeline configuration, or import it. You can't do that yet in web interface. However, it should be possible because it's no black magic, right? Adding more plugins and templates. As I told, for now there are only a few plugins and templates. Mostly they are related to building Go binaries because the team specializes in Go development. But we will add also the templates to test Python codes, build C codes, etc., etc. Workflow mechanism. This is one thing. As you might notice, when you will define pipeline, to launch this pipeline, you need to create an application. However, you might not need an application to run a pipeline. You might just want to define some jobs, some monitoring jobs or something. This is why the workflow mechanism will be introduced in the nearest future. You might just think about it like one universal application for your pipelines. Pipeline as a code. This is a feature that should allow you to versionize your pipelines, your jobs definitions with some version controlling system like Git. Currently, it's not that easy. I mean, you have to export your pipeline with command line interface, and this is what you can version. With this pipeline as a code feature, we should be able to link our CDS project with Git repository, and automatically the changes in jobs definitions will be stored there. And two last things, semantic versioning. This is this versioning you can see in many open source projects that contains 3 numbers separated by dot. It's major release, minor release, patch. For now, there is no such thing in a proper way done in CDS. We are mostly basing on build commit IDs, but the project is going to be more and more mature, so we will introduce the good versioning convention. And last thing, I mentioned that there is integration with GitHub, there is integration with Bitbucket, there is no integration with GitLab yet. It's on the roadmap, so it will be there. It's not there now. And of course, if you've got any ideas, you are highly welcome to put them here. But not only put them here, just also tell us what are your needs. Okay, so going to conclusion, what I would like you to remember is that there is such tool called CDS. It's under development, but it's currently already usable. It supports multiple backends. Mostly there are Docker-related backends and OpenStack backend. And it was designed to be highly scalable and secure for users. I mean, the isolation between jobs should be proper. About the scalability, I can tell you that at OVH, with CDS, we are building few thousands of jobs every day. And for more information, please visit our GitHub repository page. And If you just want to discuss something or share your ideas, please go to this Gitter chat room, and you can find there all creators of CDS. That's all I had for today. Thank you very much for your attention.
Any questions?
Yeah, and I would like to welcome your questions, of course.
We have time for 2 or 3, okay?
Why? Why you create another CI/CD software? What's problem you're trying to solve by creating this software?
Okay.
Additional question, why not Jenkins, and do you implement all those exceptions that Jenkins throws?
Okay. Being honest, I was afraid I would receive that question. I should put a disclaimer at the beginning, maybe. I came here as a user of CDS, not a creator of CDS. That's one important thing. And about the question you asked, why not other tools? The team I am working with, the creators of CDS, they have a lot of experience in working with Jenkins and other software. I don't want to start here a religious war. Why not Jenkins or something? I can tell you that there were some issues with scalability and some isolations between between jobs within different tools. I don't want to put their names because we reported them a bug, but they haven't fixed that yet. So mostly because of that. We've been trying to have one solution that will work for the whole company as a centralized CI/CD solution, and we tried 4 tools. No one was suitable for such amount of builds we are performing. I hope that answers your question.
Anything else?
Yeah.
One more, okay.
This project is used by any external company? Do you have any external contributors to this project?
Not yet. It was released on GitHub. I've seen there's some contributions from outside the OVH, but no big company, no other big community grouped yet. I mean, it's pretty young project. It's not more than a year old. So I'm sure no one of you, except from the OVH friends, no one of you has heard about CDS before, right? So my intention to go here was to show you that there is such thing, and you might be interested in taking at least a look.
Thank you.
And maybe contribute.
We have time for one more question. Is there something? Okay, if not, then thank you very much.
One question here.
There's one? Oh,
Yeah.
okay.
No, you said that CDS is different from Jenkins and others, but you can't say why, because you obviously don't, submitted some bugs and stuff. Is there information or some comparison between CDS and something else? Like if somebody asked me why I should look for something else than Jenkins, for example, why CDS?
Okay, there was a conference 2 weeks ago, how it was called, Bracecamp or something. There was a comparison between CDS and few other continuous delivery solutions. This presentation is not in the internet. However, we will probably create a list, as you said, and put it on GitHub one day.
Okay, as we are a bit off on time, so this was the last question. Thank you very much.
Thank you.
We have like 5 minutes of break.
Thank you.
And the next presentation will be also held in English. It's a presentation about practical aspects of Yocto by Marcin Gudajczyk from Nokia. So 5 minutes.